Hi, and welcome to this video where we're going to look at the fundamentals of AWS VPCs. Let's get started. So let's have a look at the core concepts that make up a VPC, and then in the next video we can go through the AWS console and set up a VPC. So here we're going to look at subnets, route tables, internet gateways, NAT gateways, network interfaces, elastic IP addresses, and VPC endpoints. So the first part is subnets. A subnet resides in a single AZ within your VPC, must have an IPv4 CIDR block, and that will be within the VPC CIDR block. So for example, if your VPC CIDR is 10.0.0.0/16, then the subnet CIDR must be smaller than that, so 10.0.0.1.0/24, for example. A subnet can have an optional IPv6 CIDR block. That's allocated to you by AWS. You don't kind of get to choose what that is. Subnets can have access control lists. Well, they do by default have access control lists, but it's up to you whether you want to use them and add in more specific rules to limit the traffic inbound and outbound of your subnet. The next part is route tables. So a route table is part of a router, which we've mentioned in the previous video, and it determines where to route the traffic next. So it looks at the outbound traffic of a subnet, for example, you requesting to go out onto the internet, and it says, okay, this outbound traffic is destined for 8.8.8.8, say Google, so I should send it to the internet gateway. Or, okay, this outbound traffic is for a different subnet, so I'm going to go send it over to the other subnet. We're going to have a look at this in more detail in the tutorial, where we'll set up some different route tables and show how public and private subnets work. So the next one is internet gateways. Now an internet gateway is a highly scalable device which kind of works on the AWS backplane. It allows your VPCs to access the internet, and how it does this is by basically acting as a NAT. The internet gateway hosts your public IP addresses and will do the NAT translation into your private IPv4 address space. For example, if you have a host in a public subnet, that host actually only has private IP addresses. In the console and in the metadata, it might say, oh yes, I have this public IP address. But how that actually happens is via the internet gateway, which hosts that public IP address on the web, and it will provide the NAT translation into the private IP address of that EC2 instance. So in all intents and purposes, it's a public subnet, but all those instances within that subnet actually have private IP addresses. And that's where the NAT for internet gateway comes into it. You shouldn't confuse that with a NAT gateway, which is different and used for private subnets. But an internet gateway basically allows your public instances to connect to the internet. All the route tables must also point to this internet gateway, so that would typically be a 0.0.0/0 route table entry, and then any traffic that doesn't match all the other options would go default out to your internet gateway. So the NAT gateway provides internet access to instances which don't have an assigned public IP address. So in the console you can see that you have your private IP address and maybe an assigned public IP address. For that instance to access the internet, it will have to go out via a NAT gateway, and you can do that in the route table, where again you would have 0.0.0/0, and you'd point that towards your NAT gateway. The NAT gateway has a public elastic IP address, so you can reassign that to different things. And by being assigned that public IP address, any traffic that goes through that NAT gateway will appear from that public IP address. A network interface is an interface within a VPC that has an IP address, a MAC address, and a source destination check flag. It's used for different services to communicate within your VPC. For example, you have EC2 with a network interface, and you could also have Lambda, which uses network interfaces to talk into your VPC. And there's other services that also do this to gain access into your VPC. Multiple network interfaces can be assigned to a specific EC2 instance, and that can be useful if you want to have your EC2 instance span over multiple VPCs. Right, so the next part is network interfaces. A network interface in a VPC has an IP address, a MAC address, a source destination flag, and other attributes such as security groups, which provide a stateful firewall for traffic going in and out of an instance or another AWS service. Network interfaces can be used by other AWS services such as AWS Lambda or Elasticache or other instance-based services. You can attach multiple network interfaces to EC2 instances, and you might want to use this for having multiple VPCs and then allowing an instance to talk to one VPC and talk to another VPC at the same time. Elastic IP addresses are public IP addresses which sit within your account, and you can remap these to different EC2 instances according to your needs. For example, you might have an EC2 instance with an elastic IP address. When that fails, you might remap that to a different EC2 instance, and then your clients can just use that single elastic IP address to talk to whichever instance you choose, depending on where that is mapped. This provides you some flexibility by providing you the freedom of moving those IP addresses and keeping those IP addresses, importantly. Elastic IP addresses differ from the so-called public IP address that AWS provide because you get to keep this elastic IP address. It's elastic for your needs. Public IP addresses on EC2 instances, once the EC2 instance is fully stopped and started, you'll get a different public IP address if that EC2 instance was assigned a public IP address in the first place. This is for IPv4. In IPv6, all of the IP addresses are fixed. So VPC endpoints are a new and kind of upcoming service that makes it really easy for you to connect to AWS services without having to go out via your NAT gateway or your internet gateway. They allow you to privately connect your VPC to the supported AWS services. There are two types of VPC endpoints. The first one being the gateway endpoint. Now the gateway endpoint is defined within your route table, so we've mentioned that previously, and this is for S3 and DynamoDB, where you specify in your route table any traffic for S3 go via this gateway endpoint, or any traffic for DynamoDB go via this gateway endpoint. The second option is interface endpoints, which sets up a elastic network interface within the VPC, and then your instances talk via this private IP, and that allows you to also set up some access policies to limit what instances can actually access from the service. Okay, so let's put all of these resources together to show you a typical VPC. So here we have our region of EU West 1 and our VPC. Inside that we have a single availability zone, and we could extend this to have 3 availability zones if we wanted to. So let's have a look at the public subnet first. So a public subnet, we have a couple of instances and our NAT gateway. So our NAT gateway does sit inside our public subnet because it itself needs a public IP address. So let's say this T3 instance needs to talk to the internet. So this T3 instance is going to talk to 8.8.8.8. It's going to come out, and the first thing is it's going to look at its security group. So its security group sits around the instance, and if the traffic can leave, then it's going to leave, and it's going to hit the network access control list on the subnet. If it's permitted to go through that, then it will, and then it's going to have a look at the route table. Route table is going to say, okay, any traffic for 0.0.0.0/0, so basically any, and if it hasn't matched anything before that, I'm going to send to the internet gateway. And we'll have a look at this further in the next video. And it's going to send to the internet gateway, where it's going to change its private IP address to a public IP address, to whatever's assigned to that host, and it's going to go on its merry way out to the internet. On a private subnet, we might see that we have our instances again, and then we have our security groups still, which sit around these instances. When we want to access the internet, we'll go out of our security group, through our network access control list, and then onto our private route table. Now our private route table will say, okay, any traffic should go through the NAT gateway. So what that will do is that will say 0.0.0/0 to our NAT gateway. So our NAT gateway is actually sitting in our private subnet, so it's going to send all the traffic through this network access control list back into our public subnet, through our NAT gateway, and then back out where it will be processed by this route table and up into our internet gateway. When the traffic returns, it's going to come through our internet gateway, and it's going to be routed into the public subnet, where the NAT gateway will do its NATing, and then it will be routed back through and back to our private subnet. So hopefully that provides a high-level overview of how the different components work together. In the next video, we'll walk through a tutorial of setting up a VPC and seeing how these components are configured, and then we'll spin up an EC2 instance and try and talk out to the internet. Hi everyone, thanks for watching. I hope you found the video helpful. If you haven't already, please give the video a thumbs up and hit the subscribe button below for some more great content on AWS, 3D printing and home automation.